failure. So what are the reasons of these type of failures that we have to understand effectively. So all these parameters, all these regions, all these figures point out to understand what is the strength and other properties of the material used in construction. That means if you are aware about the strength properties and maybe some other properties of the structure, then you can make it safe. So let us continue. Now, prime focus is on the strength of material. That's why this subject is introduced. First of all, which material you are going to use, whether it is concrete, cement, concrete, maybe wood, maybe steel. You must be aware about the strength parameter of the material so that you can build a or design and build a safe structure. Now, when an external force acts on a body, the body tend to undergo some deformation. Maybe initially a beam is a straight horizontal member. When it is subjected to forces, it may try to bend. So that bending will come under deformation. Maybe if there is a column and it is going under compression, it can possible that column can have deformation, column can buckle. So now what are the external forces? What do we understand by external forces? External force may be self-weight of the structure. There is a beam is made up of some material has some weight. That means whole of the beam is having some self-weight. So that self-weight is responsible or it is applying some force. Imposed load. Imposed load mean that means it is not dead load. Self-weight is a dead load, but imposed load means you are applying some load from outside. Maybe when you are using it to any type of load, which is not basically a fixed load, then it will come under the imposed. You are imposing some load on the structure. There may be some tensile force. Tension, you may be applying some tension. There may be some compressive force, twisting. That means you may be applying some movement on the structure. When you are applying some movement, then it is also known as twisting movement. So these all come under the external forces. And when an external force acts on a body, the body will try to undergo some deformation. Now, what is the meaning of deformation? Broadly, we will try to understand meaning. Deformation may be any form of as structure. As suppose there is a column can get shortened, or then if you apply some tensile force, then that member can elongate, or if it is a beam subjected to some concentrated load or some UDL, then there may be bending. So if the beam is getting bending or any structure member is getting bending, it is getting shortened, it is getting elongation, all these comes under the deformation. And what is the cause of deformation? External forces are the cause of deformation. So it is very much clear from these three paragraphs that when some external force is acting on a body, it can cause deformation. Now when deformation, what type of deformation, we will later going to explain. Now each material, that means material of the body opposes the deformation due to inherent strength. Suppose there is a steel rod, and if you are applying some force outside, suppose this is a steel rod like this is a steel rod, and you are going to apply some force outside, then what can happen? This steel member can elongate. So there will be some deformation, that is elongation type of deformation will be there. If you are applying some compressive load, it can get some compression. That means decrease in length, that is another type of, that is shortening of the member. It is also called deformation. Now what will happen if you apply some force? Then it does not mean that on the application of that force this member will get elongate. No. So if it is not getting elongate on applying the force, if you go on increasing the force, then maybe at some stage it can elongate. But before that, when it is not getting elongated, that means to the applied force, your member is responding. It is applying some, it is resisting. And why it is resisting? because of its inherent strength. The member has some internal strength. It will try to oppose the external force. Body means that material. Body will respond to external forces, which depends upon now how much response of the body, that means the resistance of the body, that depends upon the material type. Material type means whether it is RCC, whether it is steel, whether it is plastic, whether it is wood. So type of material. As you change the type of material, response will change. Then cross-sectional dimension. Depending upon what is the width of the section, what is the length of the member, etc. So all the cross-sectional dimensions will also affect the resistance to the external forces. And this response is basically termed as resistance or resistive force. Now let us try to understand. There is a member and we are applying some force from the outside. You are well aware what do you mean by the applied force. The applied force can be compressive, can be tensile, etc. So when you are applying some tensile force, what will happen? The member, due to its strength, it will resist. It will offer some resist. And this resistive force is known as reaction. Now this applied force will be called as action, and resistance offered by the member is known as reaction. So how much will be the reaction? It depends upon the properties of the material, dimensions of the material, cross section of the material. So what will be the resistive force? It will depend upon all these parameters which we have already discussed. So very important punchline is resistance force offered by material is due to intermolecular forces of the material. You are well aware that molecules of any material have intermolecular forces of attraction. When you are applying some force, then they will try to resist. And the deformation starts when resistance force is less than applied force. That means if you are applying some compressive force, suppose it is 100 kilonewton and maximum resistance offered is 90. So after 90, when you increase the applied force, then this structure, this member will get compression. It will get compressed. And if you are applying tensile force, then it will elongate. And that means we will say now the member is getting deformed. So deformation starts when your applied force is more than the resistive force. Now we can see one diagram here. What you will observe, there are two columns are there and one beam is supported. That means these columns are supporting the beam. Now this beam has self-weight. No external force is applied. Due to self-weight, what will happen? Due to gravity, this self-weight will be acting downward. Now suppose these columns are not of a good strength. Suppose these columns are of paper. These are made up of paper, but this is a steel rod. Then what will happen? This beam will go down. Now if these columns are of good strength, maybe they are of RCC or steel, then what will happen? Now this RCC beam, these column will apply or resist the movement of this beam. If these columns are resisting the movement of the beam from getting downward, that means they are offering some resistance, and these resistance are known as the reactions. Now in the second figure, you will see if this beam is getting loaded, you are increasing the load, then possibility is that this beam can bend like this shape. Now this is support, this is support. What you are observing, the upper portion of the beam is getting compressed and the lower portion of the beam is getting extended. So that means at lower portion, this is blue portion, tensile force is acting, and above this compressive force is acting. So that's why this beam is getting bent. So this is known as bending, and some bending force is applicable on it.